Segmentation of hard exudate in retinal fundus images using BCDU-Net. Contents: Introduction, release work, proof of method, result, conclusions, reference. Introduction. In this paper, we work with retinal images and provide a program to segment retinal hard exudate. To solve this problem, we proposed deep learning methods. The prevalence of diabetics in the world is increasing rapidly. High diabetes can cause change in the small blood vessels, and therefore diabetic affect vision. Diabetic retinopathy is one of the complications of diabetes that affect the eye, which can be considered one of the most dangerous complications of diabetics. Diabetic retinopathy is caused by too much sugar blocking the blood vessels in the retina and stopping blood flow. As a result, the eye tissue tries to make new blood vessels and to compensate for this animal. But these veins don't grow well in the retina. Damaged blood vessels in the retina causes diabetic retinopathy. The disease is initially asymptomatic or causes only mild eye problem, but can eventually lead to blindness if left untracked. In diabetics, the capillaries at the back of the eye can cause fluid to leak and out of the retina, causing swelling of the retina and blurred vision. And in such cases, the capillaries bleed, causing make a person's vision unstable. These complications is divided into two categories: without engineers and with engineers. The first type occurs in the early stage of retinopathy, in which blood or fluid circulation from the narrow vessel and of the retina causes swelling and deposition of hard exudate in this area. The complications does not affect the vision until it formed in the central area of the macular retina. Release work. Many approaches have been proposed for lesion segmentation. In following, we will examine one of the proposed methods. As an example, this article used convolutional network and after X and IDRID dataset were used. From the 18.2 images of the after dataset, 14 images were selected for training and 14.2 images for testing. And from the 18.1 image of the IDRID dataset, 15.4 images were selected for training and 27 images were selected for testing. The number of patches injected into the network is balanced and random. The layer size is 32 by 32 and the size of input image is 512 by 502. Finally, we have examined the result of this model in the chapter. Proposed method. We have focused hard exudate lesion to do this. We used the developed BCDU-Net convolutional network for image segmentation. Step by step. Data preparation, data preprocessing, injecting data into the network for training, then test the trained models. As following this method result segmented image of hard exudate lesion. Data preparation. And because the original images are large and have margin, that will slow down the turning process and have no results. So we will remove the margins and change the scale to 448 by 448. Preprocessing. Use the following processing algorithm. First, convert colorful image RGB to grayscale. Then normalize that. Then with Z-score algorithm. After this algorithm, the image have mean of 0 and standard deviation of 1. Then we perform normalization by changing the mean max SK, thus the data will be the range 0 and 1. Next, to improve the contrast, we use the contrast limited adaptive histogram equalization and set the clip limited parameter to 0.2. Finally, gamma adjustment to 0.18 to mask the image brighter. The output image is as shown. BCDU-Net. Being inspired by U-Net, B-convolution LSTM, and dense convolutions use BCDU-Net. Convolutional network developed for image segmentation. The network exploits the strengths of B-convolution LSTM modes and densely connected convolutions. The BCDU-Net encryption path consists of 4 steps. Each step consists of 2 Chery by Chery convolution filters by 2 by 2 max Billing ReLU activation function. The original unit may learn redundant feature in successive convolutions. To reduce this problem, densely connected convolutions are powerful, and this helps the network improve its performance with the idea of collective knowledge. Each step in the decoding path in a standard unit, the corresponding feature map is cut off the contract path of it in the decryption path. These feature maps are then combined with the output of the upsampling function. In BCDU-Net V2, B-convolution LSTM is used to process these two types of the feature maps in a more complex way. The problem with intermediate layer during the training phase is that the distribution of activations varies. This problem makes the training process very slow. Batch normalization is used to increase the stability of the neural network. We purpose BCDU-Net V2, which is added to BCDU-Net to evaluate the network from two evaluational metrics, ESC and IOU. The similarity coefficient is commonly used to calculate the similarity of two images. Of course, it can be used for any other type of data. This is also one of the main metrics for evaluating the result of medical image segmentation. This value indicates how similar results of the segmentation model are to the actual texture mask. Intersection over union. A simple metric for calculating the accuracy of predicted image with real image. Calculate the area of the overlap between the predicted and real image. They divided by the area of their onion. Similar to the risk coefficient, this metric ranges from 0 to 1, where 1 in complex overlap between the predicted image and real image, and 0 means the no overlap. We use cross entropy for loss function and Adam and SGD for optimizer. Dataset. The Indian diabetic retinopathy image database is the database of the Indian population. This includes diabetic retinopathy lesion and normal retinal structure that are labeled at pixel level and have a resolution of 2000 by 4000. This dataset provides information on the severity of diabetic retinopathy for each image. This dataset consists of 18 colored images with symptoms of diabetic retinopathy versus pixel annotation of abnormalities associated with diabetic retinopathy such as hard exudates, soft exudates, microaneurysm, and hemorrhage. It is presented as a binary mask to evaluate the performance of single lesion divided techniques. Out of 18 hard exudate images, 16 images were randomly selected for training set and 21 images for testing. Out of 16 images, 20% have been selected for validation. Training curves. We trained our proposed method on the idea this dataset. As you can see, the dice coefficient has converged with higher accuracy after 2p, and thus function training and validation curves. Results. Dice coefficient or F1 score 76%. AUC is the area under the ROC curve and is a measure of how well the network can segment the output data. 0.198. Accuracy 99%. We also see the visual result in figure. The prediction test image, the main image of the ideology dataset, true positive green, false negative red, false positive blue. Conclusion. In this paper, presented a developed deep convolutional network called BCDU-Net V2. Perform hard exudate lesion segmentation. The results showed that this method can solve the problem with 99.30% accuracy. Also, in the future, we plan to solve the problem in the realm of multi-lesion segmentation. Reference. Thank you.